Hello, Dr. Ellis here. I'm going to take you through your required practical number 9, where you're going to gather some data using a simulator online, much like you might have done for the decomposition of milk practical. Again, it's important that we do this now because when we're all back in Year 11, we won't have time to kind of catch up on these practicals that we should have been doing in Year 10. At least in biology. I know physics have a lot more time because their syllabus is a lot smaller. Lucky them. Anyway, we're going to look at ecological sampling, which you'll have done at Key Stage 3. I think in Year 8 we do it, where we go to the field, so there's nothing really different. It's just keeping it tight in terms of how you say things. And there's 2 parts to this required practical. It says in the syllabus that we need to measure the population size of a common species in a habitat, and then we're going to use sampling to investigate the effect of a factor on the distribution, how spread it is in a habitat. Okay, so that's what we're going to do, and there's therefore 2 different techniques. So in ecology there's 2 things that we want to do. Mainly one of them is find out how much is in a defined area, how much of something is there in a habitat, and it's normally part of conservation, that we've like protected this area, or the number of these plants recovering. Yeah, so you need to go and measure what's there first, and then you go back again a year later and measure again to see how much is there then. Okay, so it's finding how much is there at that time. More interesting when you do it as a one-off is to measure the distribution over a defined area. So normally to investigate why the organism is spread in this way. Why is there a lot there and not a lot somewhere else? It's never boring if you're a biologist. You can always wonder. You can always look at a wall and think, why is the moss growing there and it's not growing there? And you can investigate it. Anyway, there's 2 techniques. One's called random sampling. That's when we find out how much is there, where we sample, as in measure a small area randomly. Or we perform something called a transect. And it's really important that we get these 2 words the right way around. It's the kind of question where it's going to be the 6th marker, okay? That tends to be related to the required practicals, and they'll say something like, give a method for how the distribution of daisies could be measured in this field, okay? And you would have to give a transect answer because they're after distribution. Okay, so you need to be really careful. And ecology is a job. Being an ecologist, if you want a job where you're not in an office all day, but you get to go out and collect data, and then you come back to an office, and then you analyze the data. So if you like maths, statistical maths, and you like nature, then it's a job. If you're going to be building a new house and there's the land that needs to be assessed first, well, it's an ecologist that has to come and do the assessment. I have a friend who works for the government, and he's an ecologist, and he goes out measuring things, and he writes reports for the government on the abundance, how much of stuff there is in the country for different types of species. Anyway, so this is the simulator that you're going to use. Okay, so there'll be a link on the information. When you get on it, you can see here there's a field, there's a tree there. This little kind of square here, that's where it's being sampled. Every time I click sample, it will randomly spot that somewhere in the field. Okay, then this is the zoom in into this area. So this brown frame is the quadrat, and I just count the number of daisies. 1, 2, 3, 4, and do it carefully. And then I just sample again and sample again and sample again. I think I'm going to ask you to get 10 samples. Again, if we were at school, we'd go to the top field. We'd do this again by popping quadrats down. But quite frankly, as soon as it's sunny and people are outside, how much people learn and remember from it, I think is minimal anyway. I think in terms of remembering it for an exam, this is probably a better way of doing it, bizarrely. Because I know in my class last year, can only remember going outside, and such a person got stung by that bee kind of thing. They could remember everything apart from what they actually did. Anyway, maybe it was just them. So you're gonna have a sheet to fill in to evidence that you've done it. I'm going to give you some data from 2019. and you're going to collect some data for 2020, and then I'm going to ask you to work out some averages, mean and median. We're not going to bother with mode because there's not enough data for mode to make sense. You need lots and lots. I need like 2,000 bits of data before you can start using a mode. Okay, and then there's going to be some questions that associate with this. This is the easier part of it. Part 2, which you'll do in a subsequent lesson, there's more involved because it's, quite frankly, Transects are more interesting. In your books, this is the only kind of notes that you need. In terms of like a 6-mark answer, all the information is here. So I'm going to zoom through this now, and you can pause it and basically copy it down or add some bits to it. So there's 2 problems. How many daisies are flowering in a field? And does the distance from the road affect the number of flowering daisies? Maybe there's pollution from the traffic, acid rain and things like that. Maybe it's going to affect it. So yeah, the technique is random sampling for how many, and it's transect for measuring how something changes. In terms of the equipment you need, it's the same equipment for both, hence it's a line that goes across. You're going to need a suitable quadrat, and I'll go through what that is in a minute. You're going to need 2 tape measures, and you're going to need a random number table. Okay, and we'll see why we need them in a bit. In any practical you're asked to plan, always think about these 3 things. How can you be free of bias? How are you going to make it accurate, and how are you going to gain reliability? Okay, so in terms of free of bias, that means that I've not had an impact. So I can't just throw a quadrat because that's not random. I'm biased. It can't land where I'm stood. Even if I have to close my eyes and spin round, yeah, it can't land where I'm stood, and I would control how hard I fling it. So it's not random. We have to be more random than just chucking a quadrat, and it's dangerous. And they break. So yeah, all we do, if I've got a square field, is that we basically make an X and a Y axis. So we place tape measures along the sides of the sample area. It's sometimes described as making a grid, and you can even do it with string. You actually make lots and little sections, and we therefore, if I've got an X and a Y axis, you can pick coordinates from the random number table. Okay, so these little booklets of tables of random numbers, and on page 20 it goes from 1 to 20, and it just randomizes the numbers. So yeah, it's relatively straightforward. For a transect though, all I'm going to do is basically I'm going to walk from the road down through a field. So we need a random starting point. So this is where I can place a tape measure along the starting edge of a sample area. I'll show you this in a diagram in a minute. I pick a random starting point using the random number table, and then I'm going to sample in a systematic way. So again, in the next lesson, you'll go through this systematic sampling along a transect line. But it's worth having in your books now, so it's all together. Hence why we're doing it together. Accuracy is when something is close to the true value. Words like precision, reliability, accuracy get chucked around. Why did you repeat it? Oh, so it was accurate, precise, and reliable. We need to be really careful. Accuracy means, if I measure how many daisies there are, and Steve does the same, we get the same answer. Yeah. When how do I weigh something accurately? Right. Well, I put the scales on a surface that's flat. I set the scales to 0. I dust off any soil from the potato that I'm weighing, and then I make sure the potato is fully on the scales. Accuracy is how we do stuff. Yeah. We do it carefully, following rules so that we get the correct answer. Okay. So that's all we're going to do is I'm going to go through in a minute what a suitable quadrat is. Even just like double checking. Me and my imaginary friend Steve is the only friend I have is imaginary Steve. If we work together, I got 12. What did you get, Steve? I got 12 as well. Brilliant. We're on it, unless we're both making the same error. But then that gets into systematic errors that comes up as well. So, or you can have a thing like a counting rule as well. Reliability begins with R, so does repeat. So reliability is all about repetition. Okay, and this is where you would do not just like 3. You don't do 3 quadrat. I do 3 rolling a ball down a ramp in physics. Yeah, where there's hardly any variables. It's like, it's very, very old defined. In ecology, it's a field, it can vary, therefore I always go for a lot. Yeah, in the exam, put 20. Yeah, you're going to be doing 10 just because it gets boring doing more than that, but you're going to do 20. It says that you can use something called a running mean to decide if more data is required. That's the only difference to GCSE and A level. I've literally just done this with my year 12 class, and we can ignore the running mean bit. All it means is that you keep working out the mean and you see when the mean kind of stabilizes. So you can ignore that. All you need is that you need 20 sample areas minimum, and then you'd calculate a mean at the end. And therefore your mean is reliable because it's based on 20 bits of data. It'd be less reliable if it was only based on 10 bits of data. If I wanted more confidence, more reliability, I should do 50 sample areas. Okay, so reliability is how confident you are in something, and if you're a reliable student, you always turn up on time. You can be reliably late as well, I guess. Anyway, for transect, here we just do a mean of parallel transects. I do one, and then I do another one, and do a mean across. Other information. Often when people asked about, give a method for how many daisies are in the field, they say, put the tape measures down, 1 mark. Select random coordinates, 2 marks. Place the quadrat at those coordinates and count, 3 marks. Double check for accuracy, 4 marks. Repeat that process 19 more times, so there's 20 bits of data, 5 marks. And then they don't say how many daisies are in the field. You have to do some maths, and this is what you'll be doing. I need to basically work out how many quadrats would fit in the field. So if I get the area of the field divided by the area of the quadrat in the same unit as well. So if they both need to be in meters squared, and then I times by the mean number that I get in a quadrat. So you're going to be doing some of that maths later. And for transect, you just need to make sure that the direction is clearly given. Obviously, if I'm moving towards a road or moving away from the road, I'll get different data, and therefore it's really vital to know which way I'm going when I'm presenting the data. Okay, so yeah, distance from the road down a field, etc. So that's, you should, in your books, pop the title down, sampling, and make a little table. Again, don't worry about running mean, but say a mean is calculated. And you might want to add a little bit that I talk about now. So in terms of accuracy, yes, suitable quadrats. So if we take this left-hand picture first, you can see these. Imagine we were counting the yellow flowers. So I'll pop my quadrat down at some random coordinates, and I can count. Okay, obviously this is a suitably sized quadrat. If I was counting blades of grass, it'd be too big. So you think about the size of quadrat. Again, it'd be a suggest question in an exam. Suggest what you should think about when choosing a quadrat. Because if this quadrat was 10 times as big, I'd lose track of how many yellow flowers there are. This way, it's a countable number. I'm not going to get confused. Below, this is just I talked about counting rules. Where imagine the blue blobs of the plant. The red line is the quadrat. I've got some on the edge. Okay, and someone might count this one here as in. Someone might count it as out, or someone might say it's half. Count it as a half. We all kind of have different ways of interpretation. So they use things called a top left rule, where if it's touching the top or left, you count it. If it's touching the bottom or right, you don't count it. So this quadrat would be 1, 2, 3, 4, 5, 6, 7. There's 7 blobs for this quadrat. This one isn't counted. It'd be counted in a quadrat here though. Okay, so again, that's taking it into a level. Yeah, counting rules. You could just say double check. Yeah, count it once, count it again. If they're the same, move on to the next one. Okay, this is counting numbers. You can also measure percentage cover. So this is lichen growing on a rock. Those are my fingers. That's my dirty fingernail. I've been gardening. I've not been doing anything else that's grubby. It's just, yeah, dirt from the garden. This is lichen, the grey stuff. If I'm trying to work out how much, I can't see an individual lichen plant. Well, it's not a plant anyway. It's a fungus with algae living inside it. But I can't see an individual, so I'm going to measure the percentage cover. And here we can just go along and, well, I've got 25 squares. It's a 5 by 5 grid. 100 divided by 25 is 4. So each square is 4%. And you can just say, well, I'm going to, if a square is more than half full, I'll count it as a full square. So basically, I'm not going to count that square. I'm not going to count that square. So that's 8% less. And I'm not going to count this one here. And I'm not going to count that one there. So that's 16% less. So that's right. So that's 84% cover. So you kind of pop it on, do a quick estimate, and then you move on again. Again, takes more time doing percentage cover than counting individuals if it's as easy as this. Okay, but there's two different methods, and in a question it would say that. So we're going to do counting individuals here, but there's going to be a question in the second lesson on this where you look at percentage cover of algae growing on a tree trunk, which is going to be something to look forward to for all of you. In summary, this left-hand picture kind of summarizes random sampling. The red line is my tape measure. I put one on the x-axis, one on the y-axis. This green area is my field, and the little black squares, they're where I've randomly placed quadrats. I didn't have 20 quadrats. I've moved around here. If I was planning an experiment, I couldn't say, place a quadrat in a random place and then repeat it. Because if I repeat it, I'm telling the person to repeat that quadrat. Just count it 20 times. Boring, but you'd get an accurate count. So yeah, you have to say repeat the sampling process in 19 times, 19 other randomly chosen locations. Remember, in biology, you can get a tick if it's right, a cross if it's wrong, or you can get that upturned V if you're too vague. And biology, we get lots of those too vagueness. But yeah, this diagram sums up random sampling. Whereas Transect's, this sums it up, where I put my tape measure on the side I'm going to start from. My other tape measure goes down the field or along the field. Here we're heading north from a south across a field. If this is my first randomly chosen, so this is my first randomly chosen starting point, and I place my quadrats at regular intervals along the transect line. And then I can do another transect and another transect and another transect. So the position of these transects is randomly chosen, but the distance is the same every time. So I can do a mean of these 4 quadrats across to get a more, it's called a representative measure of the number of organisms at that point in a field. Okay, if I just did one transect, it might just go along a path, and therefore I don't get what's around me more. If I have a coffee with milk and 2 sugars, if I don't stir it, every mouthful is not representative of coffee, milk, 2 sugars. By stirring it, it all spreads out, and therefore I get every sip is, a 2 sugary, milky goodness of caffeine. Yeah. So, yeah, representative is a word that you could use, but again, we're probably getting more A-level-y, if that's a word as well. Okay, so it might be useful if you're keen, to make a little diagram of these and put random sampling on the left and transect on the right. Therefore, you get it clear in your head. So if you give a random sampling answer to a transect question, you'll get some marks for using, for randomness, quadrat placement and things, counting within a quadrat, but you're not going to get full marks because you're not going to talk about the direction that you're going to go. You're not going to talk about doing it every 5 meters or whatever you choose to say. Okay, I think that's it. Yeah, that's what I go through at A level, just to say it's the same. We just need to be a bit more careful about how we say things. But yeah, quite frankly, it's not much different to Key Stage 3. Again, you just need to avoid that vague upturn arrow, upturn V symbol.